Hi, Assalamualaikum. So we are from Group Beta, Section 2. We'll present the project presentation, which is hazard study of the transesterification in biodiesel production.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muzaffar Amin bin Rusnawi. My metric number is DD220098. So I will continue this presentation with the introduction. So hazard and operability study, or known as HAZOP, is a systematic team-based method used to identify and assess potential hazard and operational issues in a process or systems by analyzing deviations from the intended design or operations. Hazard Hazards are very crucial in many industries, including chemical processing, oil and gas, pharmaceuticals, and manufacturing for safer, more efficient, and cost-effective operations. The hazard is a systematic approach used during the design phase to identify potential risks and operational issues in a system or process, thereby preventing accidents and ensuring productivity and efficiency. It involves a multidisciplinary teams that use terms like more, less, none, and reverse to analyze each component of a system or process to identify potential deviation from normal operations. In the biodiesel plants, the hazard can be very crucial in the transesterification process since it uses many hazardous chemicals during the process. A thorough risk assessment is crucial to prevent any accidents and ensuring efficiency in the process. So, I will continue with the purpose of hazard. A hazard is utilized in the transesterification process to identify potential risks and operational issues, ensuring the reliability, efficiency, and safety of the process. So there are four purposes, which is to identify the hazard, and then evaluate the operation issue, and then improve the process design, and finally risk management and mitigation. So I will continue with the methodology of HAZOP. A HAZOP involved with a multidisciplinary group, typically including a leader, process engineer, safety expert, operation staff, and other specialists who collaboratively identify and assess potential hazard and operability issues in a system or process. So based from our study, I made an organizational chart, which is first uh, the process leader, Nur Alia Nadiara, and then safety engineer, which is me, Wan Muzaffar Amin, and a process engineer, Muhammad Saza, and then we have maintenance engineer, Muhammad Harith Sufyan, and finally quality control engineer, Muhammad Hadi Ahlami.
Thanks to the next presenter. Assalamualaikum. My name is Muhammad Harith Sufyan bin Muhammad Zulkifli. So now I will continue our presentation about methodology. In method, we separate to three parts, which is deviation, consequence, safeguard, and recommendation. For deviation, we have 6 items. First, feedback preparation. Feedback preparation have a lot of key deviation. It is identified in this phase are contaminated feedstock and insufficient feedstock supply. Next, reaction stage. For reaction stage, it's crusher for converting triglycerides to biodiesel. Next, separation stage. It is incorrect temperature or agitation setting can affect the efficiency of the process. Next, deviation is purification stage. In purification stage, it's a crusher for biodiesel quality as residual impurity and excess water content can cause the engine damage. Next, byproduct handling. In product handling, it's crusher when inadequate recovery and disposal can cause the environmental damage and non-compliance with regulation. Lastly, we focus to utilities. The inefficiencies can lead to operational challenge that have energy efficient equipment and minimizing utility failures are essential. To identify the consequences of the deviation, we have 6 consequences. First, unwanted site reaction, the equipment failures and explosion. The safety is risk of explosion and equipment rupture and work injuries. Then the impact is potential release of hazardous materials. Next, incompleted reaction reduced biodiesel yield contamination. And the safety, lower safety risk, but the potential process is instability. Third, poor conversion rates and incompleted reaction and increased waste. Next, decreased reaction efficiency, soap formation, phase separation issues. Okay. Five, formation of unwanted byproduct, soap and ester, and its difficulties in separation. Lastly, inhibition of reaction, soap formation, and emulsion creation. It's all about consequences. For each deviation, it have consequences. For the consequences, we should note the safeguard and recommendation. For the first consequences is safety valve installation and maintenance. Second, alarm and control system installation that can avoid the regulation. Third is missing system maintenance. It optimizes the missing protocol for complete the feedstock iteration. Third, which is next for the consequences for feedstock quality control. It improves the feedstock storage condition. Next is alcohol storage controls. It is optimize the reaction ratios. Lastly is water production process. We can use the water monitoring system for contamination control. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alan Nidra binti Yusuf, unit number SDD 20096. I will continue the presentation with the facilities involved for sensor refrigeration process. So for the process flow diagram, it begins with the feedstock tank. The biodiesel production begins in the feedstock tank, and then where the vegetable oils, animal fat oils, or used cooking oil are stored. Then the mixer mix the cooking oil and the feedstock with the alcohol. The mixer mix the feedstock with alcohol, with the methanol or ethanol, and a catalyst such as sodium or potassium hydroxides. And then mixing the oil ensure homogeneous alcohol and catalyst dissolution, easing the transesterification process. And then in the reactor, transesterification occurs on the combined material. Triglyceride in oil reacts with the alcohol to form biodiesel, methyl or ethyl ester, and glycerol at a controlled temperature and agitation. After the reaction, the mixture is delivered to the settling tank, and then where two phases naturally separate due to their densities. Biodiesel rise while denser glycerol sink. In the wash tank, biodiesel is washed to remove the leftover alcohol, catalyst, and soap. Biodiesel is verified during washing to meet quality standard. The dryer removes the residual water from biodiesel, ensuring that the final product is moisture-free and suitable for storage performance. And then, glycerol from the settling unit is refined in the unit. This unit removes methanol, catalyst, and also soap from glycerol, making it suitable for cosmetic and medicines. Distilling extra methanol recovery unit to reuse it future production batch, enhancing sustainability and efficiency. This comprehensive method produces high quality biodiesel while efficiently managing trash and byproducts. So that's all from me about the process flow diagram. So continue with the major equipment used in transesterification process. So we have 8 equipments that we use. But the first equipment is feedstock tank, and then we move to the mixer, and then reactor, and the fourth is settling tank, and the fifth wash tank, dryer, the seventh glycerol refining unit, and the last one is methanol recovery unit. So for detail of and function for these equipments already explained in the report. So thank you.
So I will continue the presentation. My name is Muhammad Adi Ahlami bin Talmizi. So I will present the hazard study result. So the first one is feedstock preparation. So deviation is more water use. So the possible cause is improper feedstock handling, and the consequences is reduced reaction efficiency, and the action will be taken is monitor water use. So the second one is less mixing. So the possible cause will mixer malfunction or improper mixing setting. So the consequences is incomplete reaction, and the action will be taken is improved mixer calibration. And the last one is no oil flow. So it will cause the valve malfunction, and it will have the consequences, which is process will be shut down, and the action must be taken, which is implement flow sensor. So the second one is catalyst and alcohol addition. So when more alcohol or catalyst, it will make the incorrect dosing system that cause incomplete reaction. So the action need to be taken is calibrate dosing system. The second one is less catalyst, will make the improper catalyst preparation and will cause the reaction rate reduction. So the action that must be taken is frequent catalyst do calibration and inspection, and the last one is no catalyst addition, that possible cause additional catalyst feed system will be failed. So the consequences will make that no reaction occur, and the action that need to be taken is monitor catalyst present in the process. So the third one is reaction vessel. So when more pressure, so the pressure sensor will be failed. So it will cause the explosion of fire risk. So the action is install the safety valve, and the second one is when less temperature, the heating system will be failed. So it will cause the poor product quality. So we need to improve the heat control system. And the last one is no reaction. So when no reaction, the absence of alcohol and catalyst. So it will cause the no production. So we need to ensure the alcohol and catalyst are sufficient. So the fourth one is separation of glycerol and biodiesel. So when more glycerol, it will inadequate setup for phase separation. So it will cause the biodiesel contamination, and the action is optimize the process and equipment used for separation. The second one is when less separation, it will not enough time to settle. So it will cause the low product quality, and we must optimize the phase separation by adjusting the separation time. And the last one is no separation. It will make the equipment failure, will cause the contamination, and we need to do regular equipment maintenance and calibration. So the fifth is washing and purification. So when more water, safe water will flow. So it will cause the biodiesel dilution, and we need to optimize the washing process. The second one is less washing time. So it will insufficient washing time and will cause the residual alcohol or a catalyst. So we need to increase washing time. So the last one is no purification, which is equipment failure and will cause the low product quality. So we need to implement automatic purifying control into operation. So 6 is heat exchanger. So more heat will make the cooling system failure. So it will cause the overheating. So we need to install more system for temperature control. Second one is insufficient cooling, which is inaccurate heat exchanger setting. So it will cause the reaction efficiency reduction. So we need to maintain cooling system. The last one is no temperature control. So it will cause the temperature sensor failure. So the overheating or underheating will occur. So we need to implement backup temperature control in place. So the 7 is distillation. So when more methanol in vapor phase, it will cause the leaking. So the fire and explosion risk is higher. So we need to regular sales inspection. The second one is less recovery efficiency. So it will cause the distillation column malfunction. So it will so the waste will increase, and we need to improve the column design. So the last one is no recovery. So when no recovery, insufficient heat will occur, and the cause will methanol accumulation. So we need to optimize recovery efficiency. So the last one is storage. So deviation is more impurities, which will cause the storage tank are not adequately sealed. So the consequences is low biodiesel quality, and the action must be taken, which is proper sales, maintenance, and inspection. And the second one is high temperature. So it will cause the cooling system failure, and consequences is fire and explosion risk. So the action that need to be taken is install the temperature sensor. So I think that's all from me. I'll pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazai Muhammad Safuddin. So I will present the recommendation. So for the HAZOP number 1, feedstock preparation, it is advised to implement automated size monitoring system, train operators or proper equipment handling and calibrate and maintain equipment on a regular basis to address inconsistent feedstock size. So which can be caused by inefficient chopping or grinding equipment. And then strict quality control procedures, regular inspection and installation of sophisticated cleaning systems such as automated air or water cleaning units. So for the HAZOP number 2, note to catalyst and alcohol addition. So it is advisable to implement automated dosing system with precise measurement controls, trains operator on proper handling procedures, and perform routine calibration and maintenance of dosing equipment in order to address the deviation of incorrect catalyst alcohol dose, which may arise from measurement error, equipment malfunction. It is advised to take precaution against the possible contamination of alcohol of catalyst due to incorrect handling or storage, including using sealed containers, keeping appropriate storage conditions, and performing regular quality check. Number three is reaction vessel. Implementing automated temperature monitoring and control system, performing routine maintenance on thermal equipment, and setting up alarm for unusual temperature vessels are all recommended ways to address temperature deviation, which can be caused by malfunctioning heating or cooling system and linked to incomplete reaction or safety hazard. Then regular vent cleaning and inspection, as well as routine testing of pressure relief device are advised for pressure deviation brought on by closed vent or broken pressure release system. Note number 4 is separation of glycerol and biodiesel. So the implementation of real-time monitoring system for separation efficiency, routine maintenance on separation equipment, and optimization of process parameter like temperature and hydration are recommended to address incomplete separation, which can be caused by improper phase settling, equipment malfunction, or suboptimal operating condition. So quality control procedures such as prefiltering inputs and regularly cleaning equipment should be implemented in case where cross-phase mixing or impurities in the feed have contaminated biodiesel or glycerol. For the note 5, washing purification, it is advised to install automated monitoring system for water flow and washing efficiency, regularly check and clean nozzle and optimize washing condition based on process requirement in order to address insufficient washing, which can be caused by insufficient water flow, closed nozzle, or suboptimal process parameter. It is advised to use cutting-edge filtration or absorption technologies, carries out regular quality tests, and strictly adhere to washing protocols in order to address the problem of biodiesel contamination brought on by lingering contaminant or insufficient purification. So, installing flow control system, optimizing washing cycles, and recycling wastewater through treatment system can reduce waste when excessive water usage result from overwashing or inefficient equipment. Number 6, heat exchanger. So for the exchanger the first one is implementing a routine cleaning and maintenance schedule using automatic sensor to monitor flow rates and using anti-scaling treatment or falling resistant material. So it is advised to regularly calibrate temperature sensors and install backup monitoring equipment in case of temperature deviation brought on by malfunctioning sensors or control system. So installing pressure monitoring system, monitoring system, inspecting pipes and fitting on a regular basis, and fixing leaks and blockage right away. For number 7 is distillation. So for the distillation, automated temperature and pressure control system, frequent column performance monitoring, and feed rate optimization to avoid overloading are suggested solution for incomplete separation problem brought on by improper operating temperature, pressure swing, or column flooding. So regular quality checks and feed management system and improve reflux ratio optimization are recommended to prevent contamination of distillated products due to impurities in the feed or inadequate reflux control. And then the last one is storage. So for the storage, it is advised to install level monitoring system with automated alarm and cut-off mechanism, perform a routine tank level inspection, and enforce triggered filling procedure in order to mitigate the risk of overfilling storage tank, which may cause spills or safety hazard. So it is essential to use high quality storage tanks with secure seal, maintain separate storage for incompatible materials, and perform regular quality checks to prevent contamination of stone material caused by the inadequate sealing, exposure to environment, or mixing of incompatible substance. So it is crucial to install temperature and pressure monitoring system, use temperature control concept for sensitive material, and outfit tank with pressure release system in the event of temperature or pressure variation in storage system. So for the last part, I will present the conclusion. So for the conclusion, the HAZOP study offers a true examination of possible deviation, their reasons and their effects at every crucial stage of the biodiesel production process. The study identifying the risk and making practical recommendation, implementing sophisticated monitoring and control system, scheduling routine maintenance, training operators, and optimizing process parameters specific to each node are some of the main recommendations. So certain action like automation, preventive maintenance, and real sensors address important issues like contamination, equipment failure, inefficiency, and safety risk. A strong sustainable production process is ensured by incorporating disengagement into every node, including feedstock preparation, catalyzed and alcohol addition, reaction vessel, glycerol and biodiesel, and so on. So the biodiesel production facility can attain better operation performance, adherence to safety regulation, decrease environmental impact, and improve product quality by giving priority to this issue.
So I think that's all from our group. Thank you.